We're going to go ahead and look at topic 8.2, and this is over volume of a cylinder. So the first thing that we really need to understand before we even talk about the volume of a cylinder is that we need to understand what a circle is. And I have a circle there for you. Everything that I have written on my Cornell notes, please write down on your Cornell notes. These are not very long Cornell notes. When we review the circle, we have a center of our circle, and then we have two different kinds of lines that we could have in our circle. And the first one, I'm going to draw. That line goes from one side of the circle all the way to the other side, but going through the center. And this is called a diameter. So let's write that down. It's called a diameter. And then we can have where we only have a line from the center to the edge, the blue line I just drew. And that is called the radius. And it is important that we know the difference of these, especially when we are finding the volume of a cylinder. So if my radius here is, let's say my radius here is 4, then we know that the diameter is longer than that. And it's actually going to be double that size. So we would take the radius 4, we would times it by 2, and we would get 8 for the diameter. Let's talk about if we wanted to go the other direction. Let's say that I told you that the diameter is equal to 10. Well, that means the radius is smaller, and it is actually half of the diameter. So that would mean that my radius here would be 5. We would cut the 10 in half to get our 5. So if we have our diameter, we can find our radius. If we have our radius, we can find our diameter. Why is that important? Because we're going to need to have our radius every single time when we're finding volume of a cylinder. Let's go ahead and move on to the next slide. So when we look at this slide, we're talking here about a cylinder and the volume of it. And what I want you to think of volume is I want you to think of filling. So think of a can of soup or think of a soda can. Those are cylinders. And we are finding out how much volume or how much would be filled inside the soup can or the soda can. So the first thing we want to look at is the formula. And the formula is the volume is going to be the base times the height. Well, what kind of shape is the base of your soda can? Well, we know that the shape of that base of our soda can is going to be a circle. And you can see I wrote that there. The base, the big B for base, is a circle. So if we look at my example, and I'll kind of shade it in, okay, we know that our base is a circle. So we actually need, because we shaded that, we need to find the area of that circle. We times it by the height, and we have how much our volume is. So we need to write down this formula because this is the formula we are going to use over and over and over again. Volume equals the area of that circle, which is pi r squared times the height. Volume equals pi r squared times the height. So you're going to see here that we are going to have r the entire time, not our diameter. We have to have an r. So if we look at this formula, we look at this problem, we are literally plugging our numbers in. Here's my soda can over here, and I apologize for the drawing. Okay, it's telling you that this r is 4 inches, and my height is 3 inches. So we're going to plug these numbers into our formula, use a calculator, and we're done. So volume equals, What number is pi? It is 3.14 times the radius squared. Well, radius squared means times itself by twice. So radius is 4 inches times 4 inches. And then the height of this one is 3 inches. So pi times RRH. Type that into our calculator, and we can see if we type 3.14 times 4 times 4 times 3, I'm getting 150 and 72 hundredths, 0.72. Our label is inches and volume is always cubed. So that would be the volume of this can. You're literally plugging numbers into the formula, typing them into your calculator. Need a calculator? You can use a phone. There's probably a calculator. You could Google a calculator. Desmos has a calculator. It's on my website, desmos.com, DESMOS. Or you, if you have an iPad, there's a calculator on it. So type it in your calculator. Next slide, last example. So if we look back at our notes, this problem, example 1, that was done by having a radius. Okay, we found the volume of a cylinder with a radius when line was only halfway through the circle. Now we're going to find the volume of a cylinder, but what you're going to notice below is that example 2, I gave you a diameter. I want to remind you about what our formula is. Our formula has not changed. Our formula is still the volume equals pi r squared times the height. So that's why I reviewed, how do I find my r here? If my diameter is 5.2, to find your r, you just divide it in half. And so your r is going to equal the 5.2 divided in half. We want half of the length of that line, not the whole length. So my r here is 2.6. Now that I know my r, that's probably the hardest part, is making sure you always use your radius, half that line, not the entire line. So as we go ahead and we plug our numbers in for example 2, we have volume equals, what do we plug in for pi? 3.14. My r here is 2.6. We times it by itself, 2.6 times 2.6. And the height here we see is 14. And when I plug in pi times 2.6 times 2.6 and then times a 14, we have 297. And if we want to round to the nearest tenth, 0.17. Your label on this one is not inches, it is centimeters. So centimeters and cubed. The reason it's cubed is we have a 3D shape here, and we are finding the volume of that 3D shape. How much can fit inside the cylinder? That's what volume means. So we are going to have practice over the next day. And that practice, be careful, there's going to be a diameter, and sometimes there's going to be a radius. You always use the radius. I hope everyone is well.